So the key idea in this lesson is to use the skills that we've been doing, which are our simultaneous equations, and link that to the idea of line equations. Now here I've got two line equations. This line here, which has equation y equals minus a half x plus 11. What that really tells us is, if I take a point x, y on that line, then that equation holds true. So if I take my x coordinate and I half it and I put minus in front and add 11, I'll get the y coordinate. Similarly, if I pick some point on this line, let's call this one x1, y1, x2, y2, and I take that point, then when I put those in there, if I do 2/3 as the x coordinate and I add 19/3, I'll end up with the y coordinate. So that's what that equation means. That means at this point here, well, what's true at that point there? Well, the x coordinates of this must match up. The y coordinates must match up. So it's a solution to the pair of simultaneous equations, which is these two equations here. So that point of intersection, so this is my point of intersection, is the same as asking you to solve these two line equations simultaneously. So let's just write those down and then we can work with them and see where we get to. Now, this is like what we were doing in task 2. We need to do some rearranging first. These are messy. The first one, I'm going to multiply everything through there by 3, so that is 3y equals 2x plus 19. And I'll do one more little change. I'm going to take the 2x off both sides, so I get 3y minus 2x equals 19. This equation here, I'm going to multiply everything through by 2, so I end up with 2y equals minus x, or minus 1x, you can write that, plus 22. And then, again, a little bit more rearranging, we end up with 2y plus x equals 22. So now I've got two equations which I can easily solve simultaneously. It takes that bit of rearranging before we can kind of make them look familiar, but this is a standard simultaneous equation. So we're going to do equation 1 times 2, equation 2 times 3. That's going to give us 6y minus 4x equals 38, and 6y plus 3x equals 66. That's equation 3 and that's equation 4. Then to find, well, I'm going to try and keep everything positive, so I'm going to do equation 4, take away equation 3. 6y take away 6y is nothing. 3x take away 4x, minus 4x, sorry, is 7x. 66 take away 38 leaves us with 28. And so x equals 4. Now, we can put that back in anywhere we like, but that looks like the easiest place to put it in. So we're going to put x equals 4 into y equals minus a half x plus 11. So that gives us y equals minus a half times 4 plus 11. Half of 4 is 2, so that's minus 2 plus 11. And so y equals 9. Now, there's one extra detail here that we need to go back and think. What sort of thing have we just worked out? We've worked out a point of intersection. So instead of stating our answers as x equals 4 and y equals 9, we've got our point of intersection has a coordinate 4, 9. And that is our point of intersection that we're looking for. And we always state it as a coordinate rather than as x equals 4, y equals 9. So that's example 1. I'm going to do a second example like that, just so you can follow that one as well.